Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to continue along with the book Clean Code by Uncle Robert C. Martin. Today we're going to be talking about objects and data structures. If you guys remember last time, we discussed Chapter 5, which was all about formatting. So how you structure the code within your specific files within your project. A couple highlights. If you guys remember, we talked about grouping pieces of code together that form a conceptual affinity. So I guess a basic way to put it is code that makes sense that they should go together. Keep those pieces of code just together without any spaces between them. And then when you have separate lines that deviate from the code that was just mentioned, that's where you create spacing and you have that like in another block or another lines of code. We talked about horizontal formatting. We talked about vertical formatting. We talked about how long a file should be. Files shouldn't be super long. What else did we talk about with formatting? Vertical openness, vertical density, vertical distance. Lots of good stuff in that chapter and stuff that I typically do use at work, especially with horizontally. We do have rules in place where you don't want a line of code being so long widthwise. And at a certain point, it makes sense where you just indent or you actually hit enter and then you have lines of code on the next subsequent lines, even though it can all go together on one line. So that was last time. Today we're going to be talking about objects and data structures. This is kind of my wheelhouse. This is what I normally work in. I work in Java primarily, and then we have a front-end app at work that we also work on. But this is how I started my development career, Java, Spring Boot stuff. So let's dive right into it. This is going to be a little bit of a chapter. There we go. Data. Was this the first slide? Yes. Data abstraction. So if you guys remember, in one of the earlier chapters, I had trouble with this word abstraction. I think it was with the functions and saying how functions, was it with the functions? And I was having trouble defining what an abstraction is. And an abstraction is something that you just abstract, like you can pull something out of it. I think it was with functions because functions should follow like a single responsibility principle. We talked about this before. So if a function is doing other jobs or other duties, you can abstract those out and have those within separate functions. That was one of them. I think there was another example that I was using this abstraction word. But to continue on, abstraction basically just means hiding implementations. So yeah, this kind of goes with the function example. You know, you have a function where all you want this function to do is just add items to a list, right? Maybe a list you pass in as an argument. And in addition to adding it to the list, you print out the item that you're adding to the list. Or all of a sudden you are maybe doubling the quantity of that item because maybe that item is an object, right? So you're doubling the item attribute of that object. So you can kind of tell the original purpose of the function is all of a sudden getting larger than the scope of what it actually should be. The function, you just want it to add items to a list. But now it's quickly becoming, okay, you're printing, okay, you're changing the attributes. So let's abstract that out. Let's hide the implementation. Let's hide the fact that you're doing those two other changes to it. We'll abstract that into another function. That's kind of what abstraction means. And there's like here, I'm talking about a concrete class, but there's also abstract classes where you can extend abstract classes and you can create blueprints off of that abstract class that then have the attributes of that abstract class. The reason why you would want to do this is because maybe you have other classes that are going to contain similar attributes at a base level, but you're going to have little minute differences in all the children. Perfect example, you have an animal class. Maybe that's your abstract class. But then from that, You create a lion class. You create an elephant class. And each of these extends animal, because an animal is going to have teeth. An animal is going to have limbs. An animal, I mean, most animals, I guess. Well, yeah, because you could have 0 limbs, I guess, maybe in a snake or something like that. But so you guys see what I'm doing there. You're able to use the abstract class as your blueprint or your base. Anyway, maybe a little bit outside of the scope. Data abstraction deals with hiding the implementation. So in a concrete class, you have getters, you have setters, and you use the getters and setters to push the variables out there. So here you have a circle class, right? And this is a concrete class. I know I don't have getters and setters here. I just took this from ChatGPT. But you have an instance variable in radius. You have a multiple argument constructor. Well, a single argument constructor here. This is how you would create objects using the new keyword. And then you have this calculate area method that's a part of this class. And then below this, you'd probably have getters and setters, right? So this is a concrete class. It doesn't extend or implement anything. Pretty standard stuff. Well, how about if a class exposes an interface? So when you create an interface, you're essentially creating a contract that a class has to follow. The methods that are within the interface are nothing that's going to be implemented. You're not going to see any functionality within the interface. So what I mean by that is you see in the example interface shape, which contains the method calculate area. You don't see the innards of calculate area. That's the job of the class that's going to be implementing it, which is what you see in the circle class above. It is implementing, and there really probably should be, or maybe this is just me trying to have two different examples here, but class circle implements shape. It's going to need to take on the methods of that interface. So class exposing an interface allows for the manipulation of the essence of the data without having to know its implementation. So it's going to allow Circle to implement and manipulate the calculate area method in its own manner and fashion. Because if I have a square class, I might calculate, actually you are going to calculate area differently. That's going to be length times width. So it's going to look differently than the calculate area in the circle. So what does this do? This allows you to implement it in different ways, but without having to know specifically how it's being implemented. It just allows for it. Let's see. We do not want to expose the details of the data. Very true. And that's going to be like a common theme within this chapter is for in your classes or in your objects, you don't want to expose the data. I guess that's like the main thing the main thing that you guys should take away from this chapter is that you shouldn't expose data that you don't want to. You don't want to expose the details of your classes. That's going to be kind of the main theme throughout this. Now, there's data structures where you do want to do that. And we're going to talk about that in a few slides. Actually, right now. So there's this anti-symmetry between these two things. So you have data and objects. So objects hide their data behind abstractions and expose functions that operate on that data. So you have a calculate area function method. You know what? I won't go back to the last slide. You guys remember it. You have the circle class, right, that had the area, calculate area. Now, think about this. It's exposing an area attribute, but it doesn't have it as an instance variable, which means it's not accessible readily. Now, you could have it be private, but you're going to have getters and setters, right, where you can get area or set area. In this case, without exposing the radius of your circle, you can still get the area by having a method that calculates it for you. And all you have to do is just call that method. And it's not going to expose the radius instance variable. If you guys catch my drift on that, hopefully that kind of makes sense. You don't want to expose the radius instance variable, but you do want to give customers or users an area. So you're going to do that in a separate method of that class. So objects hide their data behind abstractions, expose functions that operate on that data. So that's the one side of the anti-symmetry. Then there's also data structures which expose their data but have no meaningful functions. So this could be something like a data structure, a list, a stack, a set, an array, a hash map. You can readily access data within those data structures, but they don't really have any meaningful functions. You can't really perform calculations. There's not a, list dot sum all, list dot print all. At least I don't think there is. There is like list dot length, list dot size. There's array dot length. But anything meaningful that operates on the data structures don't have that. So you can see that there's an anti-symmetry here. They're kind of opposites of each other. And then Uncle Bob later, he talks about this procedural code. And this kind of adds to the anti-symmetry between objects and data structures. So procedural code versus object-oriented code. And you can see object-oriented code has to do with objects, procedural code more so with data structures. But procedural code makes it easy to add new functions without changing existing data structures, but it makes it hard to add new data structures. Now, object-oriented code is flipped. So in object-oriented code, it's easy to add new classes without changing the existing functions, but it makes it hard to add new functions without changing all the classes. And I think I got an example of this on the next slide. The procedural code part, I might come back to. That one, I still have trouble understanding it, but the object-oriented code makes sense to me. It's going to be easy to extend classes and just obtain the attributes of your base class, right? Because you have the example we were talking about earlier, you have your animal abstract class, and you're going to have tons of animals. It's easy to create new classes. And you don't have to change the functions from your animal abstract class. You can just keep everything. It's going to inherit it, right? It's going to take on that contract. And I get abstract classes and interfaces they're similar, but there are certain differences to it. We don't have to go over all of them in this video, but object-oriented code, extending classes, creating new classes, easy. But when you want to add new functions, it makes it hard. Because when you want to add new functions, like, okay, what do animals do? Animals have like a mating call, right? But you didn't add it originally. So now you go to add it to your animal class, and now the other subsequent classes now have to change because they need an implementation for that mating call. And maybe this is where one of the key differences in an abstract class is I don't think you have to take on every single method in there. But if you need mating call for all your animals in your particular app, then you're going to have to implement it in all the other classes, and it could take time. Maybe you have a lot of classes that inherit from that animal, that extend the animal class. Now, in procedural code, it's the opposite. Like I said, when you want to add new functions, it's easy because you're not tied by this extension of a parent class. You're not tied down by that. So you can just add a ton of functions to one class file. You can just do that. But when you want to add new data structures, that's where it's going to be potentially difficult. Like if you want to add like a brand new list of animals, let's say, that's where it's going to get a little bit difficult. That's the part, the procedural part is I'm still having a little bit of confusion with procedural code and why, if I go back, why it's going to make it hard to add new data structures in the procedural code. So sorry if I'm not explaining that. Maybe this next slide is going to jog my memory a little bit. Jog my memory. What do we have here? Okay. I think this example. Oh, okay. Okay, so I think this is the procedural code example. So an employee DTO, let's take a look at the one on the very left. You have an employee DTO, and then you have an employee class. DTO, data transfer object. You're really just going to expose the data that you want. So you're going to be creating employee DTOs versus employees for saving into a database, getting stuff out of a database, etc. We're going to talk about that in another couple slides. But you see, the employee is an object with behaviors. It's going to have a promote behavior. It's going to have a calculate salary behavior. And that stuff is going to utilize the instance variables, which are private, which you're not going to have direct access to. And you're going to use promote and calculate salary to give a user the meaningful data from employee that it needs without giving it all the instance variables. Now, you could also use an employee DTO to expose the instance variables that are most meaningful. Like, not even looking at that example, maybe you really just want your employee DTO just to have a first and last name. You want to keep the email private. You want to keep their age private. Hey, you shouldn't ask people about their age, right? So you're going to keep that stuff private. And not even just private. You're not even going to have it in your employee DTO. And you're just going to have getters and setters for your first and last name. That's using data structures. And data structures, a DTO is an example of that data structure. The employee, the public class employee, that's the object-oriented design. So in the top right, we have an employee DTO. Okay, it's exposing certain instance variables. Okay, it's going to have getters and setters, we're assuming, in other fields. But here's where it's going to be problematic in adding a new data structure. Okay. Because if I want to add an address DTO now, what did I say over here? Makes it hard to add new data structures without changing the functions. I think that's what I meant to put there. So when I add an address DTO to this employee DTO, the getters and setters, I'm going to need to add getters and setters. I'm going to need to change the repository call methods, or just the repository methods on this employee DTO in order to get it to shove into the database, because now we just added a new column, address. So the repo methods are going to have to change. The service call methods, where you're presenting the data, like the business logic, that's going to need to change. So it's problematic to add the data structure because the functions are going to have to change. And it's the opposite in object-oriented. I think that's what I'm doing in this bottom right example. So getters and setters, new function added without modifying the DTO class. Right, it's easier because it's easy to add functions. It's easy, right? Isn't that what I said for the procedural code? Oops. Makes it easy to add new functions without it changing existing data structures. Right, so top right, I'm adding a data structure, problematic because other functions are going to have to change. Bottom right, you're adding a new function, totally fine. You don't have to modify the DTO class for that. Yeah, you can add promote employee, but it's not going to change the fact that you can still post this to the DB. You can still expose the instance variables that you want to expose. This works out. This works out. And what was this example? Okay, so this is the object-oriented. This is kind of the object-oriented, showing on the left, it's showing the difficulty in adding a new function. So in an employee class, right, this is not a DTO. This is object-oriented design. If you got your private instance variables, you have a new function that you want to add, but it's going to be potentially difficult because why? Because it makes it hard to add new functions without changing all the classes. All the new employee objects that you created using the new keyword potentially could have to change because you added this promote employee function to it. Now on the right, what do we have here? You have a public class manager, which extends employee. Gotcha. So it extends employee. It has access to promote employee. So you're going to need to have some sort of implementation for promote employee in the manager. Now think about if you have salaried employee, you have hourly employee, you're going to have to promote employee is going to have to change in each and every one of those. So again, not to belabor the point, it's going to be easy to add new classes. You can add a hourly employee, you can add a salaried employee, but if you want to add new functions to that employee class, you're going to have to change all the other classes with it. In the procedural code, it's flopped. You can add the new functions. It's going to be hard to add the new data structures without changing the functions. So all this to say, and to continue on this point of this law of Demeter. And the law of Demeter says that a module should not know about the innards of the object it manipulates. We've kind of already been talking about this. That's why you create an employee DTO in order to hide all the instance variables or the certain instance variables that you don't want a user to know. So you have an employee DTO. Or you create functions that present meaningful data without exposing the instance variables that are a part of that class. So that's what the law of Demeter is saying. You shouldn't know about the innards of the object you're manipulating. This goes for a lot of things. It should hide the data. I don't know why I said that, but it shouldn't know about the innards of the object. And then it basically also says that you should hide data but expose operations. Hide the age and the email and the salary of your employee, but expose the functions promote, clock in, etc. Expose functions, hide data. And again, just this kind of goes along with it. Objects should not expose internal structures through accessors. So yes, you could just call, object dot first name, object dot email, object dot salary, right? But it shouldn't expose those, right? So those should be left private. You shouldn't have access to those. But you should also make sure that you don't have getters and setters where you could easily do that as well. But I know getters and setters are like a very typical thing in classes. You generate your constructor, your getters and setters. And I think with the name he used for that was a bean structure, but we're going to get to that in a second. Basically, the law of Demeter, in its more precise terms, says that a method F of class C should only call the method of C, an object created by F, an object passed as an argument to F, or an object held in an instance variable of C. So a function of F. So you have an employee class, right? Function F promote employee. Promote employee should only call the methods of the employee class. So promote employee should only call the getters and setters of employee. Promote employee should only call an objected, that's funny, should only call an object created by F. So an object within that function, it should only call that. It should only call an object passed as an argument to F. So maybe promote employee, you're passing in the employee that you want to promote. And also, F should also only call an object held in an instance variable of C. So maybe the employee class has an object of desk number or desk, right? And then desk contains desk number, etc. So F should only be able to call objects held as an instance variable in C. Hopefully that makes sense for you guys, because yeah, I did have an example here. Pardon the red spacing there. Did this in IntelliJ with the help of ChatGPT to generate some of this. So we have a customer class, right? Now look at that. Customer class contains a shopping cart, a shopping cart variable named cart, right? So you have checkout, which is a method within customer, and look what it's doing. Checkout is able to call on the cart.getTotalPrice. That's following the law of Demeter, right? That's following the law of Demeter. Look at add to cart. And it's following the law of Demeter because the function checkout is a part of customer, and customer contains an instance variable of cart. Now check out add to cart. That you are passing in an item object, and that's okay because, again, a method F of class C should only call the method of an object created by F or an object passed as an argument to F. So that's okay. That's okay. And then we have the shopping cart below. That contains a list of items. And you see there, you have a get total price. That's exposing data without exposing the individual price of each item. You're just giving out the total price because that's what matters to your customer probably, or within your app probably. And then on the right, kind of a similar situation. I think the example on the left is a little better. I mean, the one on the right adds to it because we're calling payment service in the customer class as well. But if you see there, you have private variables in the item class. You don't want to expose the individual price of an item, but totally fine if you want to get the total price. Get the total price of an item. And that's where, okay, yeah, you would have to use the getter there. To do that, to do that. But maybe you could even make the get price method private, and then you could still access it as long as it's in the same package. So if you wanted to further encapsulate it, as what they say, I'm pretty sure you can do that. If it's private, if a variable's private, you can access it, but only within the package if it's in the same package. So maybe that could be another extra way to follow the law of Demeter. Train wrecks. Oh boy, yeah, I've had a lot of train wrecks. This section. If things are data structures, it's okay to expose their inner workings. 100%. Data structures, it's cool to expose their inner workings. However, if it's an object, you should not expose the data. We've kind of talked about this in the previous slide. So what if data structures simply had public variables and no functions? And then what if objects had private variables and public functions? Essentially here, this is kind of what I was saying just in the previous slide. I mean, yeah, private double price, right? That's a private variable. It's not public, but the get price method is public. The getter there is public. So essentially what you find yourself in is what Uncle Bob calls hybrids, where You have public accessors and mutators that make private variables public. Ultimately, Bob says you should avoid this, and you should follow the law of Demeter. You should follow the anti-symmetry that we were talking about with objects and data structures. And if it's an object, don't expose the data. But if it's a data structure, completely fine to know the data. So just don't get caught up in a situation where you're making hybrids. And again, that's where you have private variables, but we have public accessors to those variables. You can still see the inner workings of that object. So, hiding structure. Again, objects are supposed to hide their internal structure. So we should not be asking objects about their internals. So, instead of getting the information, you create the information. So, look at these two examples here. This is kind of essentially kind of doing the same thing. What was he doing here? Essentially, you've got the first bullet point, right? Context get scratch directory option dot get absolute path. This is potentially exposing a variable, potentially sensitive information because you're getting the absolute path of maybe like a file or something like that. And you're just getting it. We don't want to get information from an object. We want to create information from the object. You don't want to expose how much your employee makes, but you do want to pay your employee, right? So you don't want to reveal the salary instance variable, but you do want to call the method pay employee. You guys catch my drift there? So instead of getting the absolute path, why not create what you need to create? So that's what Uncle Bob does in the second line with that buffered output stream, because essentially he's getting the absolute path in order to create an output stream. So why not just do it all in one fell swoop? Instead of calling to get the absolute path, call create scratch file stream. So you don't have to expose the data. You guys catch my drift there? You don't have to expose that potentially sensitive information of the absolute file path. You can just create the buffered output stream, because that's ultimately the end result that you want from getting the file path. That's just the first step in it, but you can hide it within the function. You can hide it within that create scratch file stream. And you don't have to expose your absolute path there. Yes, as promised, data transfer objects. Yes, sir. So data transfer objects are like what you saw with the employee DTO. They are public variables and they don't have functions. And I think maybe some of my examples had a comment for getters and setters, but they typically don't have functions because these are just very useful for, like the examples there, communicating with databases. You can save to a database, get information out of a database, or you can, another example, I'm not familiar with this, but parsing messages from sockets. I guess, yeah, that if I'm thinking about this from like a run to run or like maybe event messaging, an event message comes in, you consume the message and you just write it directly to a DTO, which is the pertinent information that you need. And a DTO is kind of what is referred to as a bean. Somewhat more common, this is reading from the book, somewhat more common is the bean form shown in listing 6.7. Beans have private variables manipulated by getters and setters. The quasi-encapsulation of beans seems to make some OO purists feel better, but usually provides no other benefit. Okay, so kind of what we were saying earlier with the hybrid. Yeah, sure, your variables are private, but you can access them publicly. It's kind of what a bean is doing. Because when I hear bean, I think about it from a Spring Boot perspective where anything annotated is a bean, or you can annotate things as beans, and then they're within the Spring context. But another thing that Uncle Bob talks about is this active record. And what is an active record? Well, an active record is a special form of a DTO, and they are data structures with public variables, but they typically have navigational methods like a save and a find. Typically, these active records are direct translations from database tables or other data sources. So they are in charge of creating separate objects that contain business rules. And their generally good course of action is to keep the active record as a data structure versus an object or something of object-oriented design. Keep an active record, and this kind of goes right along with what we've been talking about with data structures and objects and a DTO. For an active record, you're using an active record for the sole purposes of just writing it to the database. Hey, a user registers for our website, creates a user object. We have a user class. But in order to save that user's email, first name, last name, phone number, address, what have you, we're not going to save it as a user object. We're going to save it as a user DTO. And we're only going to save in the database what we need. Maybe for security purposes, we don't want the password. Or rather, we do want the password because we want to change it. You need to be able, a user needs to be able to log in. Or yeah, you need to be able to change it or update it later. But maybe you don't need the address. So we're not going to save it in the database. So special forms of DTOs that deal with translating things from database tables. And it's important to just keep active records as data structures. I mean, they are a special form of DTO. Keep it that way. Keep the instance variables public. Don't have functions in them. Or maybe you could have functions in them. You could have functions in them, says Uncle Bob. Or rather, no, you don't have functions in them, is what he's saying. The solution, of course, is to treat the active record as a data structure and to create separate objects that contain the business rules and that hide their internal data, which are probably just instances of the active record. Okay, gotcha. So, user active record, right? No functions in there, but you do have a user class that can operate on the user active record. That's where you would perform maybe business logic like change password or, unsubscribe or, buy item, what have you. Next slide. Oh, and there you go. I had an example on it the whole time. So yeah, that is kind of what I'm doing here. User extends active record. Right. Okay. User extends active record. So it's going to be cool. It's going to be okay that the user has all these business logic-y methods in there. Get password, set password. But as far as active record is concerned, that's not going to have any functions in there. Keep that like very DTO, very basic. And you can see here, yep, you got your getters and setters. That's okay in the user. And maybe it's extending active record, so it has access to the save, delete, find by ID, find all methods. These in the database operations probably come from active record, right? And then you're able to implement it into whatever way that you want. So, to conclude, objects expose behavior, hide data. I think that's what I mentioned to you guys earlier. If you take away anything from this chapter, objects should be exposing behavior, should be hiding data. Objects make it easy to add new objects. You can add new classes all you want, but it's hard to add new behaviors without changing all the children classes. Another huge, super important point, data structures complete opposite. Feel free to expose their data, but they don't really have any significant behavior or functions behind them. So it's easy to add new behavior to data structures, but it's going to be hard to add new data structures to like your DTOs, because then all the other DTOs are going to potentially have to change. And adding new data types or adding new behaviors? That's the question. That's the question that you should be asking yourselves. Do I want to add a new data type or do I want to add a new behavior? Where am I adding this? Am I adding it to a data structure, procedural code, or am I adding it to an object, OOP related code? And think about the cost-benefit analysis of doing that and what's going to be easy to do and what's going to be hard to do. And that's going to do it. Guys, thank you so much for listening. I really, really appreciate it. Next time, we're going to talk about Chapter 7, error handling. Please go check out the podcast. I have a new full interview coming out with Dennis Merlot, wrote a book on football and the Detroit Lions and the fondest memories of the Detroit Lions not doing very well. It was a fun interview, very fun interview. And guys, just thank you so much for listening. Tune in next time. My name is Chris. This is Chee-Tash. Take care.